Okay, welcome to this tutorial. Today we'll be looking at geometric mean of triangles. We are given this diagram. We want to get the relationship between the variables, that's the letters ax, h, y, and b. So we are going to use what we call similar triangle theorem to solve this, to get the relationship, the geometric mean of the triangle. So looking at the diagram, we have three right angle triangles. We have three right angle triangles. The first one, we have three right angle triangles. So we have the first P. Okay, let me call here. PQS. Let's here be X. So I'll first relate in triangle. As I'm saying that triangle PSQ. Triangle PSQ is similar to triangle PSR based on right triangle similarity theorem. So the two triangles are similar by that. So which implies that the ratio of the corresponding sides are proportional. The ratio of the corresponding sides. So I'm saying that here, okay, if here is theta, you notice that here will be 90, or this is 90. If here, remember now we're looking at the bigger triangle, right angle, so here should also be 90 minus theta, and you know here is 90. So meaning that the ratio of the corresponding sides, so x over h will be equal to h over y. Yes, because x corresponds to h, that's in triangle PQS. X corresponds to h in triangle PSR, which implies, therefore, h is now square root of xy. So this is the first formula that is very important here. So meaning that once you know h, you can find the value of, once you know x and y, you can find the value of h. That's very, very important. Again, triangle P, the bigger triangle now, PQR, is similar to triangle PQS. Yes, check it. It's similar because they are both right, the same logic because of right triangle similarity theorem. So which implies that the ratio of the corresponding side. So look at the bigger triangle. The hypotenuse is x plus y. So I'm saying that x plus y corresponds to, what was the hypotenuse of this? A. Corresponds to A. Y, the leg of this triangle, the bigger triangle, PQ, which is also A, corresponds to X. Check it, the bigger triangle. The hypotenuse x plus y corresponds to A. Y A corresponds to x. A of the bigger triangle, that is the leg of the bigger triangle, corresponds to x of x, which is the leg of the smaller triangle. Therefore, A is now square root of x times x plus y. Very, very important. This is another important formula. Again, the bigger triangle PQR is similar to triangle the small, which is triangle PRX. The same way, right triangle similarity theorem. So the two are similar by the theorem, which implies that again x plus y over, where is the other leg, b, must be equal to b over y. Check it. The leg b of the bigger triangle corresponds to y, the smaller triangle, because here, check it, here is theta. Do you get? So the bigger one is opposite theta, while the smaller one here, y, is opposite theta, so that they correspond. Therefore, b is square root y times x plus. This is a very, very important formula. Very, very, very important. So you note this. Let's add extra stuff here. Let's add extra. So assuming we are asked to find a over b from equation. Therefore, a over b is now a is square root x times x plus y. S plus y. Yb is square root y times x plus y. So you notice that we bring the two together in the same square root. So what do you notice? This one cancels, so we have square root x over y. Therefore, a squared over b squared will be equal to x plus y. So it's possible, again, very, very important, that we might be given x and y. We're asked to find a over b. It's very, very possible. Very, very possible. So let's now go over to some question. Let's solve some question on this. Okay, these are some exam questions we are going to solve now using what we've learned, the geometric mean of triangle. Looking at this, we are asked to find the value of h plus c plus d given bd and dc. Without wasting time, we know that from what we've solved before, that h must be square root of 4 times 9, which is 6, square root of 36, which is 6. Yd must be square root of what? 4 times 4 plus 9, which is square root of 4 times 13, which is 2 roots 13. And c must be square root of 9 times 4 plus 9. Square root of 9 is 3. Why this has no perfect square root? So we are now asked to find h plus c plus d. Therefore, our answer h plus c plus d is 6 plus 2 roots, 3 roots, 3 root 13 plus 2 roots 13. 2 plus 3 plus 2 is 5, so we have 6 plus 5. 6 plus 5 root 13. So our answer is A. So that's using our geometric mean formulas. So the other one, we asked if x plus y equals 3b, find the value of y plus x. Y plus x. If you remember what we derived, remember, look at this, xy, x over y is a squared over b squared. A squared over b squared. So let's go over to the, so we are looking for over b squared. That's it. That's what we mean. So let's now get a squared and b squared. From the diagram again, you know this is the hypotenuse of this. This is the x plus y is the hypotenuse. So I'm saying from Pythagorean theorem that x plus y squared must be equal to a squared plus b squared. Why? Pythagorean theorem. So, and they told us s plus y is 3b, so we have 3b squared equal to a squared plus b squared, and 3b squared is 9b squared minus b squared over equal to a squared. Just I made a squared the subject of formula, which is 8b squared. So a squared must be equal to 8b squared, and we asked to find what? A squared over b squared. Therefore a squared over b squared must be equal to 8. So our answer is A. Our answer is A. So the next question, we asked to find the value of h. Find the value of h. I think the best way to solve this thing is using area of a triangle, of a right triangle. If you remember, okay, that area is always area of PQR is always half base. Remember, the base is our, I'm taking this as the height, h as the height. So half base is QR. And remember, QR is now, this is the hypotenuse of this. So QR must be the hypotenuse, which is now 6 squared plus 8 squared, all in square roots, using Pythagorean theorem, times h. Also, the area, we can still take the area as half base times taking 8 or 6 as the height and 8 as the base. So it could be half times 6 times 8. Yes. This, we have two right triangles, so I can take it in this way, taking 6 or 8 as the height or the base, or I will take h as the height, while QR is the base. So from here, half, this is 10. So h, which implies that h is now 48 over 10, which is 4.8. That's our answer. You don't need to waste your time. So finally, we are asked to find the area of this triangle. The best way the best way I will solve this is to draw a perpendicular. Yes. So this is my height. This is my height. And remember, this is 2. So meaning from here to here is 2. Since this is 20, here to here is 2. Meaning from here to here must be 18, since from this 0 to 20, so here is 2, so here must be 18. So that's it, my height. So remember, from our geometric mean, h must be square root 2 times 18, which is 6. So our therefore area is now half base, which is, our base is 20 times height, which is 6. So our answer is 60. So that's it. So this is very, very important formula. That geometric mean solves any question of this form. So thank you.